Okay. So we know that if a polygon has n sides, then the sum of all of its interior angles is n minus 2 into 180 degrees, right? And they have given that all of the interior angles are in AP and the smallest angle is 120 degrees. So of that AP, this will be the first term, so that is A, and the common difference is 5. And we have to find out the number of sides of the polygon. Okay, so let the number of sides of the polygon be n. So equating this to, on other side we can write an equation of summation of AP. So we know that is n by 2, 2a, so that is 2 into 120, so that is 240, plus n minus 1 into d, and d is 5, right? So n minus 1 into 5, this will be n minus 2 into 360 is equal to n 240 plus 5n minus 5. Dividing the whole thing by 5, we have n minus 2 into 72 is equal to, so that is 240 divided by 5 is 48n, plus we have n square minus n, so 48 minus n plus minus 72n will be 25, so we are left with n square minus 25n, and 72 2s are 144 is equal to 0. So this is a quadratic equation and the roots of this equation are 16 and 9. Okay. So first let's check for n is equal to 16. So this is the last term of the AP. We know that any term of the AP is calculated in the form a plus n minus 1d. Okay, so using that formula over here we have 120 plus 16 minus 115 into 5. So that is 195. Okay. And we know that the common difference is 5 degrees. So obviously there will exist an angle of 180 degrees between 120 and 195. So can a polygon with an angle of 180 degrees exist? It will be something like this, like A, B, C, and this whole thing is 180 degrees. So this is not possible, right? Because AC will form a line simply. So this case is not done. So n is equal to 9 is the only answer. Now moving on to part B of this problem. We are given that the interior angles of a convex polygon. So what is a convex polygon? It is basically a polygon with one of its angles greater than 180 degrees. Okay. So the interior angles form an AP with common difference of 4 degrees. We have to determine the number of sides of the polygon if the largest interior angle is 172 degrees. Okay. So we don't know the smallest angle, so we don't know A of the series, but we do know the last term. So let us assume that there are n sides of the polygon. So 172 degrees being the last term will be A plus n minus 1 into the common difference, that is 4. Okay. Again using the same principle we used in the last sum, n by 2 into 180 is the sum of all of the interior angles, and this will be equal to summation of the AP. So that is n by 2, then we have 2a plus n minus 1 into 4. Alright. So over here we can see that a plus n minus 1 into 4 is equal to 72 degrees, and here we have 2a. So splitting this in a and a, we can write this whole thing as 172 degrees. So doing that, we have n by 2 and then 172 degrees, and then substituting a from here we have 172 minus n minus 1 into 4. Alright, so this is equal to n minus 2 into 180 degrees. Okay, so simplifying this, we get n minus 2 into 180 is equal to n into, we will cancel out 2. So we are left with 172 minus 2 into n minus 1. So writing this in a quadratic equation form, it will become, so this is 180n minus 360 is equal to, we have 172n minus 2n square plus 2n. Okay, so it will be n square plus 3n minus 180 is equal to 0. Okay, so we have divided by 2 and we wrote it in a simple quadratic equation. So the roots of this equation are n is equal to minus 15 and n is equal to 12. Okay, so minus 15 can obviously not be the answer, so our answer is n is equal to 12.